this could work.
So I just also wanted to mention that the same API, peer connection API, is also available in ortc lib, so you can either develop against the new object straight away, or you can stick to webrtc 1.0 API. And what I'm finding that people do as a test case, they start out with the 1.0 API just because they're familiar with it from historical reasons, and then they move over to ortc because they discover, oh, I could do this and I could do that if I could bypass this layer. And so that's what I've seen from an evolution perspective. So I just want to talk about different models for how you could be doing things with ortc. So we're all familiar, or most of us are, how STP works, where you have party A and party B, and they both do an STP exchange, and they both agree upon a common set of parameters. So party A has these codecs, party B has these codecs, and what you end up negotiating is the combined availability of both sets of codecs, and you're agreeing upon a state. With ortc, you don't need to do that. What you can do is something like this. You can do what's called a capabilities exchange. So you can say, if you want to send me anything over the wire, make sure it conforms to this. Like, yeah, I have these payload types, I have these header extensions, I can support all these different capabilities for my codecs. And you do that. You just send it to the other party. And what the other party can do is it can either start streaming you data right away, and you can look at the RTB listener to basically event new streams as they come in. You don't even need to signal them anymore. Or you can signal down only the parameters, saying, I'm going to send you a stream on this SSRC, and it means that. And all you need to do is signal a minimum amount of information. You can dynamically just signal that part of it, as opposed to signaling everything all at once. So it allows you to much easier dynamically add streams on the fly, which is great if you're talking about conferencing scenarios or a bunch of other scenarios. So capabilities is what I'm capable of, and parameters is the detailed settings of actually what's going to go on the wire. So the other thing I want to mention is, okay, we want to move to an ortc model, which is a lot more flexible, but what if you're dealing with a legacy world? What if you have something that only talks STP? How do you handle that? Well, one thing you can actually do is make sure that the STP never hits the wire. So what you can do, if you're talking about the Peer Connection 1.0 API, is you could literally, in your application layer or some external thing, generate the STP you want for that service. You use a set remote description. I forget the name of the API now. Yeah, so you give it to the browser, and now what that does, instead of create offer, you set it as if it's a remote offer, even though you generated it locally. And what that allows you to do is you basically are beating the engine into submission. You're basically saying, I'm going to make you conform to these codecs, to these parameters, and this is how you're going to operate. So now you're going to use these payload types, you're going to use these settings, and that's all I want, and that's all I care about. And then it'll give you your answer back. You might get some SSRCs or parameters out of it for your streams that you've added, and now you can just signal that part of it up. So even though you're dealing with a legacy system, you can almost treat it like it's ortc and just give it the settings you want it to use out, and that you want it to conform to, and then you get the parameters out, which you can send to the remote party and make it a lot more dynamic through that model.
And I would mention that these functions that Robin has showed there, convert to offer, extract STP settings, those are all functions that are part of adapter.js. So all of this code is already written for you, and you can just incorporate it.
True, that's a very good point. So we're actually got a significant amount more time, so we can take some questions now, but if you have any so far, and then we can cover a few extra stuff, we got a little bit more time.
Okay.
Hi. Yeah. On one of your slides, you showed that you were able to get the list of available codecs, but you're doing that on the RTP object instead of the specific source. Why is it on the RTP stream? Presumably the RTP stream
Yeah, so
any formats, and it's going to be the source, like the camera or whatever, that's going to be deciding what codecs it can generate.
Okay, so in the web model of Get User Media, the track that comes out of Get User Media does not have a codec, so it's not associated with a codec. The codec gets chosen either in WebRTC 1.0 by the negotiation, the offer-answer negotiation, or in ORTC by the settings. So what we're going here, it's a little bit small, but basically I'm calling the function RTP receiver.get capability. So I'm basically asking the receiver, hey, what codecs do you support? Right, so the receiver basically has a decoder, and the sender has an encoder, and so you interrogate these things and you say, encoder, what can you encode in? And decoder, what can you decode? So the camera acquisition basically doesn't bring codecs into play. It just essentially, in the abstraction, the track is basically a media stream which has not been encoded or decoded.
Any other questions? Going once? Going twice? Big round of applause
No,
for
we're not
these
done.
guys.
We're not done. We're not
Oh,
done.
you have more. You have
Just
more.
one
You have
more.
questions. Okay.
Yeah.
All right. Go ahead.
So, yeah, we have a whole bunch more stuff, but we just wanted to take basic questions here. Okay.
So I also wanted to mention there's ORTC Lib, and there's also 2 other projects that are associated with that, and that's for the Windows Universal Platform, so UWP. So if you're developing a Windows Store app that allow you to run on standard Win 10 or Xbox or HoloLens, you develop for the UWP platform, and you can do that. So there's 2 projects that are straight up WebRTC 1.0 from Chromium, which you can use. It's open source. And there's ORTC Lib UWP, which is ORTC Lib that already is cross-platform inherently.
So one of the things that we're seeing is the WebRTC UWP SDK is popular among people who have a website and want to basically use SDK to communicate between a website and, say, a mobile app or perhaps some other embedded system. The ORTC Lib is very popular among gamers who are just trying to interoperate among their game, or in embedded systems when they don't have a website, they're just trying to do embedded kind of work. Or of course, it's also very popular, I guess, on the HoloLens as well.
Shockingly, a lot of questions about HoloLens. So just to overview some of the features that are in there, you can build, as I mentioned, native apps. You've got the peer connection API, either directly through the WebRTC UWP project or through ORTC Lib, which has an adapter project, but essentially the same API.
But the footprint is considerably lower for ORTC Lib.
Yes, it is. Okay. You've got the ORTC API. Obviously, that's only in the ORTC API project. You've got the data channel, so you can use that in either project. You've got a whole swath of codecs, which you would expect. It does support hardware accelerated H.264 to give you, which is really important on mobile and lower end systems, because it really gives you a lot more frame throughput that you get otherwise. The standard Opus, G711, G722 codecs, DTMF. And I'm giving you a whole bunch of links of where you can find these. You can also download NuGet packages. So if you're from the C# world, you, instead of having to compile all of this source out of GitHub, you can instead just take down the package and start using the APIs immediately, which is a really nice little feature that Microsoft offers in the UWP platform. And there are some samples available that you can use, and if you find bugs or issues, just tell us. We're happy to fix.
Those include HoloLens samples as well for rendering.
And I just wanted to mention a few things about the ORTC Lib project, and I separate them from UWP because ORTC is a cross-platform library. You can target UWP, you can also target other systems as well. And we've got a lot of enhancements in the ORTC Lib regarding the mobile stack. So we have, not only do we have trickle ice, we have things like if we detect the network starts to fail, we'll start to do multipath, so we can actually switch hot swap from one path to the other, so you can switch from Wi-Fi to LTE on the fly and do stuff like that. It's kind of neat. We have enhancements to the media layer. We have a lot of control over simulcast. We've integrated VP9, for instance. I wouldn't recommend that on mobile because it'll kill your device. But if you're talking about the desktop, you can actually set all the different layering parameters in a detailed fashion, because that's what you can do in ORTC. You also have SDES if you want to do that instead of DTLS. We've got extensive platform support. It is fully 1.0 compliant for the ORTC API. And we're seeing great things in terms of faster setup time, because we have prioritization where we'll try and establish the connection, for example, over turn first. It's just automatic. You don't have to hold back the candidates. And then we prioritize, we optimize down to start the connection first and then optimize the connection after. So we do things like that in ORTC Lib, and it is compatible with WebRTC. Although you might not get some of these enhancements without it.
Yeah, tomorrow, well, because they're not, okay, on the schedule, it's not marked when the talks stop.
That's not me.
So we're going to do that tomorrow. We're going to clarify before the day starts when the talk.
Okay, well, I'm going to continue. I'm sorry to be rude to whoever's talking, but
Like on
the other thing that I will mention, sorry, this is really difficult.
And I had marked at 11:40 stop.
Is it possible to
She's going to
hunt them down? Yes, okay. So the other thing that we concentrated on is make sure the battery life on mobile is handled better. So if you put the application asleep, it handles it. You bring it out of the background, it handles it. We try to support the embedded devices, as Bernard was saying. It does support unidirectional capabilities, which you would expect out of ORTC. You don't need to be bidirectional communication at all. And we're trying to make it easy. So you can just clone down the repo, one script. You don't have to install a lot of stuff, except for your compiler maybe, and go. Or you can just grab the NuGet packages and you go if you're in UWP. And we're trying to make sure that these are future-proof, because we're trying to make sure that all the APIs that are in ORTC are available to you in ORTC Lib. And the final thing, which I think is really interesting, is we have advanced diagnostic capabilities. So if you want to see what's actually going on without running Wireshark or something like that, or detailed-wise, there are literally thousands of events that you can extract out of ORTC, and they're remotable. So if you're on a one device, like a Mac or an iOS device or Android device, you can literally remote connect to the device and have the diagnostics rendered in a nice GUI that's available through the Windows Performance Analyzer, and you can see all the details on a timeline and be able to go down to each detailed event and see what's going on, including the details of the packet that's going on in encrypted or decrypted fashion. Obviously, you don't want to open that up to the world, but it's great for diagnostic capabilities, and it's all visual.
Okay, so here are some information on what's going on in the W3C. As I mentioned, I'm co-chair of the WebRTC working group, and so you can get hold of the WebRTC specs by going to this URL. One of the things is the WebRTC specs are now more or less continuously updated, and so you can look at them and in particular see some of the object model changes. They're in the last editor's draft as well as whatever's currently there. In addition, there's a lot of work going on in WebRTC statistics, which you may be aware of, a lot of updates and new cool stuff, which Taylor Branstetter from Google talked about on, I guess it was yesterday, Tuesday. In terms of the ORTC, we have the ORTC community group. The specification is up on GitHub, or you can just get to it at draft.ortc.org. And some exciting things happening there, including support for Quick. I would like to take you through a few code examples of how things are done in the object model in WebRTC, as well as in ORTC, and the differences between them. This is I think I'll do the change camera example. This is a pretty simple one. So basically in WebRTC 1.0, you would do, for example, add track to add a video track, and then you would take the track and call sender.replace track to replace that track with another video. So an example would be you want to switch cameras, you start out with a track from the front camera, and you can just call replace track. You'd acquire the track from the back camera, and then you'd call sender.replace track to basically replace the camera and switch between the front and the back. Another example would be, say you wanted to send a screen share in addition to the video, and you're switching between the screen share and the video, you could use replace track to do that. The equivalent call on ORTC is setTrack, but basically it does the same thing. Really, the only difference there is the call you use to get your sender. On ORTC, you just do new RTP sender to just create the sender. before you set the track. Example is sending codecs. Basically, in ortc, what you do is you create your sender, and then you create your codecs, and you just call send to send the codecs. Actually, before that, you can do sender.get capabilities to figure out what codecs are supported, and then munge the list, and then call send. On webrtc, basically, you do sender.get parameters, and that tells you what, basically gives you the equivalent set of parameters, and then you could look in and see what codecs you do. You can also reorder the codecs if you wanted to, say, set H.264 higher, or take a codec out, you can remove it. And then again, you call set parameters to set the new parameters.
And I also wanted to mention something here that's really important. If you're used to how you used to do things in webrtc, a lot of people would change their preferred codec by manipulating STP and then plumbing it back in. You're no longer allowed to do that. You have to use these APIs to be able to change the ordering or do stuff like that. So it is important to learn how these things work.
Yeah. So another example is setting a maximum bit rate. This is, there's an attribute called max bit rate, and basically what you do, again, in webrtc 1.0, you'll add the track, you'll get the parameters to, and then you'll set the max bit rate to 1,000 in this particular case, and then you'll call set parameters, and then that bit rate is then reflected. In ortc, you just set the max bit rate in the encodings and call send. So this is an example of enabling and disabling media. You can, basically the control there is there's an attribute called active, and so you can set active to false for a particular encoding to turn it off. And you can do this actually in webrtc, you can only really do it on the sender, but in ortc you can do it on either the sender or the receiver. In this particular case, we're showing them both on the sender. And so again, the way this example works is you set encodings.active to false and call set parameters. And then if you want to set it to true again, you set it to true and call set parameters again. And on ortc, you basically call send, and then you can manipulate the state of the encoder.
And before you go on to this next point, I just wanted to mention regarding the webrtc 1.0 object model. In some cases, when you change properties, they have to do an offer-answer exchange, and sometimes when you change properties, they don't. So
yeah, so actually let me, that's a good point. I'd like to clarify that. So basically, the way to think about this is all these parameters I just showed you, max bit rate, active, don't involve an offer-answer negotiation. They're kind of unilateral changes that you make. So a decision to basically turn off an encoding is just something you can do. It's like, I'm not speaking right now. I didn't have to negotiate with you whether I stopped, I just stopped. And so in webrtc 1.0, basically the changes you can make with set parameters are only those that won't set the on negotiation needed flag. So that's an important thing to understand. But you can go through the spec and read basically how it works, and it'll be clear. It should be relatively clear as to when you can just call set parameters. Basically, if you end up setting on negotiation needed, you'll get an error back. Your promise will be rejected or something.
And in ortc, there's never a mandate to do any signaling. It's up to you to tell the other party if you need to get a setting from one party A to party B. How do you get it there? So,
okay.
And the final part of this that I wanted to cover, oh, there's a time right there. Scalable video codec. I just want to cover a little bit about what it is. So before I do that, I wanted to talk about what are the difference between SBC and simulcast. So SBC basically sends media in layers. So what you'll typically have is a base layer of media, which is like, for example, a frame sent every 7.5 seconds. You're sending a frame, and then you'll add in between, you'll add enhancements to that where you say, now I want to go up to 15 frames a second. Well, I'm going to add in a new frame to that, and I'll say, okay, my base is 7.5 frames a second, but I'm going to enhance this base layer by adding a new frame every 7.5 seconds. Now I'm up to 15 frames a second. So Why is SBC important? It's important because what it allows you to do with the server in between is you can drop these enhancements. So if you're communicating from party A and party B and party C, it might be that A is sending some media up and sending 30 frames a second. Party B can handle 30 frames a second, is all happy, but party C does not. And what you want to avoid is you want to avoid re-encoding for the sake of this other party, C, that is not capable of keeping up. So instead of re-encoding